All right, let's talk about something that's running inside every single .NET app, whether you realize it or not. We're going to pull back the curtain on automatic memory management. Yep, we're diving deep into the garbage collector, and I'm going to show you how to make it your app's best friend instead of a mysterious foe. You know the feeling, right? Your app is humming along just fine, and then, bam, it stutters, or it just freezes for a second. Even worse, it crashes. You're probably thinking, is it my logic, a database call? But what if the real problem, the real culprit, is the very system that's supposed to be keeping things tidy? So let's meet the hero of our story, the garbage collector, or GC for short. It's basically the unsung champion of the .NET runtime. Its whole job is to automatically handle your app's memory. The best way to picture it? Think of an automated cleaning crew for a busy office. As your app works, it creates objects and then, finishes with them. It's leaving trash all over the place. The GC is the one who comes in and cleans it all up so you don't have to. Now, the GC is smart. It doesn't just clean everything all at once. It uses this really clever strategy based on a simple idea. Most objects don't live very long, so all your brand new objects, they get tossed into what's called Generation 0. Think of this like the little trash can right under your desk. It gets emptied constantly. Now, if an object survives that cleanup, it gets promoted to Gen 1. That's kind of like the main kitchen bin in the office. It gets cleaned out, but not nearly as often. And if an object is tough enough to survive that, it gets promoted to Gen 2, the land of the long-lived veterans. This is the giant dumpster out back. It only gets emptied when it's absolutely necessary. This whole system is super efficient because it lets the GC focus most of its energy on Gen 0, where most of the action is. So how does the cleanup actually work? Well, it all starts with the mark phase. The GC basically goes on a hunt. It starts with the roots of your app, things like global variables and what's currently running, and it follows every single reference from one object to another. Anything it can reach, it marks as being alive and in use. If an object doesn't get a mark, well, that means it's garbage. Okay, so after marking all the important stuff, the next logical step is the sweep. This is exactly what it sounds like. The GC just goes through memory and gets rid of all those unmarked objects. Boom, they're gone. And all that memory they were using is now free again. But we're not quite done. After the sweep, your memory can look a little, well, like a slice of Swiss cheese. You've got live objects, then a hole of free space, then more objects, then another hole. So the final step is compact. The GC literally shuffles all the surviving objects together side by side, getting rid of all those empty gaps. And this is super important because it makes creating new objects incredibly fast later on. Okay, so this all sounds perfect, right? An automatic system that takes care of all the mess. But, and this is a huge but, there's a catch. To safely do all this marking and sweeping and compacting, the GC has to hit a pause button on your entire application. It's often called a stop the world pause. Now, for those quick Gen 0 collections, you'll probably never even notice it. But for a big, full-blown Gen 2 collection on an app using a lot of memory, that pause can be long enough for a user to actually see it. A frozen UI, a stutter, and that is the trade-off we as developers have to deal with. And that brings us to the number one villain in this story, the memory leak. In a managed environment like .NET, a leak is a bit different. It happens when you're totally done with an object, but you accidentally leave a pointer to it somewhere. A classic example is a static variable or an event handler you forgot to unsubscribe from. The GC comes along, sees that reference, and thinks, oh, someone still needs this. So it leaves it alone. It can't clean it up. Back to our office analogy, it's like you've put a big do not discard sticky note on a bag full of old banana peels. The cleaning crew is just going to follow the instructions and leave it there to rot. So knowing all this, knowing how it works and where the pitfalls are, the big question becomes, how do we work with the garbage collector, right? How do we write our code so that its job is easier, which means fewer and shorter pauses for us, and ultimately a faster app? It really just boils down to being mindful of your memory. First off, try not to create a ton of new objects inside tight loops. That just makes a huge mess for the Gen 0 collector. Second, if you see an object that implements iDisposable, that's a huge red flag that you must dispose of it, usually with a using block. Third, just be super careful with static variables. They live for the entire lifetime of your app, so they're a major cause of memory leaks. And finally, for objects that are really expensive to create, you might want to look into something called object pooling. And yeah, let's double-click on that last one, object pooling. It's a really cool technique. Instead of constantly doing this create, use, destroy cycle, you just create a bunch of objects up front and put them in a pool. When you need one, you borrow it. When you're finished, you just return it to the pool. This can dramatically cut down on the number of new allocations, which means way less work for the GC. It's a game changer for high-performance code. Now, you might be tempted to just take matters into your own hands. You'll see this method, GC.Collect, and think, hey, I can just tell the GC exactly when to run. Let me give you some friendly advice. Please don't. Forcing a garbage collection is almost always a bad idea in production. The .NET runtime has these incredibly complex and fine-tuned heuristics to figure out the perfect time to run. When you call it yourself, you're usually just messing up that rhythm and making performance worse. Seriously, just trust the runtime. It's smarter than us. So, how do you even know if you have a memory issue in the first place? Well, you don't have to guess. There are some fantastic tools out there. The diagnostic tools built right into Visual Studio are an amazing place to start. You can see how much memory you're using and track objects. And if you need to go deeper, you can use things like the Windows Performance Monitor to watch the GC counters and really understand what's happening under the hood. And that pretty much wraps it up. The garbage collector isn't some scary, unknowable black box. It's a powerful ally, but you have to understand how it works to really get the most out of it. By writing code that's mindful of memory, we can build apps that are way faster and more reliable. So, I'll leave you with one final thought to chew on. Based on everything we just talked about, what little memory leak might be lurking in your code right now? Thanks for tuning in.